Hi guys, so here is the screencast for how big is a mole, basically going through Avogadro's number. Now you're going to see in this one, you're going to have to do some math. You're just going to have to do some addition and some very basic dimensional analysis. You're going to be converting from moles to grams, which like I told you in the last video, we are going to be using those molar masses as conversion factors now. So you're going to have to be able to calculate those things. So I'm just going to kind of take you through a little bit of this. There's really not much reading in this one. Most of it is just practice problems. Um, so I'm going to explain to you how to do this a little bit. So in this first one, it asks you what the atomic weight of zinc is. The atomic weight is what's on the periodic table, so 65.38 grams. If it asks you what the mass of 1 mole is, that's called the molar mass. And that's going to give you the units of 65.38 grams per 1 mole. So that's what you see down here. So that tells me that for zinc, if I had 1 mole of atoms, which would be 6.022 times 10 to the 23rd atoms, how much would it weigh on a scale? I would weigh out 65.38 grams. The cool thing is I can now use this as a conversion factor. I can use this to convert from grams to moles because I know that this is how many grams are in 1 mole. What if I had 2 moles? What if I had 3 moles? What if I had 50 moles? I can use that to determine how many grams are in there. So if it was for a compound, we could also do the atomic weight and the molar mass, which is the mass of 1 mole. All you have to do there is just add up everything. So I have 2 atoms of nitrogen, so 14.011 times 2. And then oxygen is 15.9994. So all I do is just add that up and I get 44.02 grams per 1 mole. So grams per mole again. That's the molar mass. If it was just the atomic weight, it would be grams or it would be atomic mass units. But those numbers are going to be the same. So that again just tells me if I had 6.022 times 10 to the 23rd atoms of dinitrogen monoxide, which is what that is, it would weigh this much. It would be that much on a balance. Now, the cool thing is, like I said, we can do basic dimensional analysis. This is what stoichiometry is. If I said that I had 0.450 moles of N2O, well, I know looking up here that that's the mass of 1 mole. What if I had less than that? What if I had 0.450 moles of dinitrogen monoxide and I wanted to know how many grams that was? So I know I don't have a mole, so I know it's going to be less than 44.02, but I can do just a very simple stoichiometry dimensional analysis setup. Remember, this is what I'm starting with, so that's what goes on the starting line, 0.450 moles of N2O. If that's what's on top, that's what has to go on the bottom because when I divide, I cancel. I don't want moles anymore in my answer. I want grams. That's what mass means. So whenever it asks you for the mass of something, it wants grams. So I have moles on top, moles on the bottom, and I know from calculating the molar mass up here that this is how many grams there are in 1 mole. So this is how many grams there are in 1 mole. So I'm just going to multiply. Everything across the top you multiply. If it's on the bottom, you divide. And so this tells me that 1 mole weighs 19.8 grams of N2O. I still have to worry about sig figs. This might not be what you get out of your calculator. But the starting number has 3 sig figs, so my answer is going to have 3 sig figs. So basically, that is what all the problems have you do. They're either setting you up going through calculating using the periodic table for the first half of them, where all you're doing is just telling the molar mass, whether it's for an element or for a compound. The second part of it does have you do more of these conversions, where it says, okay, using this molar mass, if I have this many moles, tell me how many grams it weighs. So you're basically doing the same setup in all of the problems. You're starting with a mole amount and you're just converting it to grams, which is very useful because grams is what we can measure on a balance. I can't measure moles on a balance. I'm sure as heck not going to count out how many atoms there are and put those on a balance, but grams is something that I can work with. That is a unit that I can work with. So the next part of this has you start going through some chemical formulas or some balancing chemical equations, looking at the coefficients and using that chemical equation to tell how many grams of a material you might need. It's basically the exact same thing. Like it'll say when 3 moles of hydrogen and 1.5 moles of oxygen react, they form 3 moles of water. Okay, well, how many grams of water were formed? So I have 3 moles of water. I just convert that to grams. The next one, how many grams of hydrogen were required to form 3 moles of water? Well, it says I'm starting with 3 moles of hydrogen, so convert that to grams using the molar mass. So all you have to do is just take what it gives you and what it's wanting and convert that from a mole amount to a gram amount using the molar mass for that compound or for that element. The main thing to remember though are those diatomic elements: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Um, if you had me in the past, I had you label those on the periodic table. Those exist in pairs. So when you are figuring your molar masses for them, you have to make sure that you do it as H2 or as O2, not just as hydrogen or oxygen as single atoms. You need to think about it in terms of that molecule. So it does take you through that also in these practice problems. So hopefully that kind of gets you through the how big is a mole Avogadro's number lesson.